So last week we looked at derivatives and well, it wasn't actually last week, it was actually a month ago, but yeah, we started looking at derivatives and I said I would teach you how to find the actual derivatives of a function. So there are different rules. Um, okay, so first there is power rule. Power rule. Then there is uh, product rule. Product rule. Quotient rule. And there's more, but they're not as used maybe, or I'm just forgetting them. So let's start with power rule. So what is power rule? Well, we have power rule is just, for example, let's say f of x equals um, x squared. This is the most simple one. So power rule, what it tells us is that f prime at x, which is just the derivative of f of x, is 2x. How did I get this? Well, the general formula for power rule, so power rule is the derivative, so y prime is equal to x to the, I will say constant. Constant is k, so k equals constant. So y prime equals x to the k minus 1 k. So what does this mean? Well, let's try another example. Let's say f at x equals, let's say, uh, 4x cubed. Then f prime at x equals 12x squared. How did I do that? Well, I removed 1 from here, and I multiplied this 3 to that 4. So I got 12x squared. Now let's try something a little bit more complicated and we can move on. F at x equals, that's an x, f at x equals, and let's say we have um, 1 over 4 x to the 4. What's that going to be? Well, f prime at x equals x cubed. Well, how is this? How did this happen? Well, this 4 came here, multiplied, then I subtracted 1 from it. So this 3 is this, and this is actually a 1 times x because it's 4 over 4, which is 1. Now let's move on to product rule. Product rule pretty much tells us that if we have f of x equals, uh, actually I will rephrase that. Y equals f of x times g of x. What is this? Well, f of x and g of x are two different functions. Two different functions, it can be anything. It can be, let's say, x squared times 5x, right? It can be any of those. Now, they have to have the same variable. So you can see that these two functions are have the same variable. So make sure you have that in order to proceed with the product rule. So what does the product rule say? It says that if you have this, then y prime equals, and then it's going to be f prime at x, g of x, plus f at x, g prime at x. It doesn't matter the order, but this is basically it. Now let's do some examples so it's easier to understand. Let's say we have y prime equals, now let's say x squared times 5x. Well, you can do this in two ways. One way is to, this was a bad example because you can just multiply them. Let's say you have uh, root x times 1 over x. It's also a bad example, but whatever. We'll stick to it. So, what do? Well, you can do this. I should probably get some examples. Yeah, for next time. So, what do? Well, we know that root x, what is root x, first of all? Root x is x to the 1 over 2. So if we take the derivative of that, it's going to be 1 over 2 x to the negative 1 over 2 times 1 over x plus root x times negative 1 over x to the 2. Because what is 1 over x? 1 over x is x to the negative 1. Now, let's look at something different. These were actually really bad examples since I could just expand these. I'll give you a better example right now, like this one. Let's say you have root. No, actually, I don't want roots. Roots are complicated. Let's do this. 3x plus 5 times 3, no, not, let's get rid of 3's, 2x squared. Well, what do you do now? Well, y prime equals, now we're going to take the derivative of the first part, and then we're going to just leave this part alone. So it's going to be 3, no, that is not it. What is the derivative of 3x? It's just 3 because we subtract and it's multiplied by 1. So it's going to be 3. And then what's the derivative of 5? Well, it's x to the 0 actually here. X to the 0 is 1. So when we multiply x to the, when we actually take the derivative of x to the 0, it's going to multiply by 5. And the 0 is going to multiply by 5, and it's going to make everything equal to 0. So it's 3 times, and then this is going to be 2x squared. We have to multiply this by 2x squared. And then we're going to do plus, and then this is going to be, now the same bracket as before, plus 5 times, and then what is the derivative of 2x squared? It is 4x. Now we can probably simplify this a little bit. by saying 3 times 2, that's 6x squared plus, and then this, oops, that's not a nice plus. And then the other one's going to be 3x times 4x, that's 12x squared, plus 5 times 4, which is 20x. And then you can simplify this even more by putting these two x squareds together, which is 4, so I can't do basic math, 18x squared plus 20x. And factoring is very important, so I am going to factor this a little bit by taking out an x, but before I take out that x, I'm going to I'm going to take out a 2. So I'm going to get 2x times 9x plus 10. That is product rule. It's important to memorize this equation right here. This formula, I mean. So you have derivative of the first times the second plus first times derivative of the second. Just make sure you try all the possibilities and you'll be fine. Make sure you don't have the same function multiplying by itself, and then you'll be fine. Okay, now let's move on to quotient rule. This one's important because sometimes you have stuff like this. 3x plus 5 over 2x. Now what do you do here? Well, you can't divide by 2x because this 5 does not have an x. So what do you do? Oh, and this is not supposed to be y prime. That's supposed to be just y. Now y prime, before we get into this, actually, I should probably teach it first. So we have f of x over q of x. We call it q because it's called a quotient. Now quotient rule says this should be f prime of x times q of x minus f at x times q prime at x all over q at x squared. Now why so complicated? Because it works. So I'm gonna put a box around this. So what would be a good example for this? Well, we have y equals, and then, yes, the one I was going to do, 3x plus 5 over, and I'm not going to simplify this one because this is going to be crazy, 2x. So what is y prime? Y prime equals, so first we take derivative of the first of the top. So what is that? We have 3x plus 5. So what can we do with that 3x plus 5? Well, the derivative is just going to be 3 times 2x, because it's the bottom, minus, and now we just put in the top, plus 5, times, what's the derivative of 2x? Just 2, all over 2x squared, which is actually 4x squared. That is quotient rule. Now, there are more things like what is the derivative of, even though you might not use it right now, what is the derivative of e to the x? It is e to the x This is really a very special function. So if you want to find the derivative e to the 2x, well, I should probably explain chain rule before that, actually. So chain rule. Chain rule is probably the most important one, where it goes like this. So y equals f of g of x. This means that g of x is within f of x. So what is y prime? Y prime is f prime of g of x. So you do not modify g of x times g prime at x. This one is very important, probably more important than quotient rule, because quotient rule you will be using less than chain rule. So uh, let's think of an example. Well, y equals, let's say, uh, 3x plus 5 squared. Now there's two ways to do this. You can either expand or FOIL this bracket right here and multiply 3x plus 5 times 3x plus 5 and then take the derivative of everything. Or you can do this. Y prime equals, and then first you take the derivative of the outside, so 2 3x plus 5, and then times the inside. The inside is just 3. So then you get, it's going to be 6. 6 times 3 is 18x plus 30. This is it. I'll expand it and all. So that was easier. Now let me introduce again e to the x. Now e to the x, we can remember, is special. So what if we have e to the 2x squared? What do we do then? This squared is just within the x. So what do we do then? Well, if y equals this, that has to equal there, then y prime equals, and then it's just going to be e to the 2x squared, then it's going to be times, right? And then it's going to be 2. What's a derivative of this? So 2, and then it's going to be 2 times 2x, which is equal to 4x e to the 2x squared. Seems a little bit complicated, but it's not. Now let's think of, for example, what is the derivative of ln of x? Ln of x is equal, so if y equals ln of x, then y prime equals 1 over x. So let's say we have ln of 3x plus 5. Then y prime equals 1 over 3x plus 5. These are simple ones. Then you can multiply it by, let's say, 5. So here you're going to have 5. Maybe by also a negative, like that. Remember, constants do not change. Only variables change. So, well, constants do change. So let's say we have 5x. 5x is going to turn into 5. But if we have a constant by itself, so if we have a constant factor, then it stays. But if we have a constant term, like just 3, it'll be 0 because we add an x to the 0 in front of it, which multiplies by 0. Now we have different things as well. We have all the trig stuff like y, so sine x. We have cos x. Oops. We also have tan x. And we have other ones as well. So what is the derivative of sine x? It is, of course, cos x. Now, why is that if we think about it? Oops, that is supposed to go more in the middle. So if we go like this, right, and our sine x and our cos x is like this. Oops. Oh, damn it. No. Like this, right? Then you can see that at the beginning it's going up. I should probably use a thinner point. There we go. It's going up and a different color. It's going up and it is over 0 here. So over here it's over 0. Then it is going down. Over here it's less than 0. Then it's going up again. It's over 0. And here's the end of the period. I should probably mention that. So over here. So did we learn that cos x is actually the derivative of sine x? Now let's go back and see what the derivative of cos x is. It's actually negative sine x. And I don't want to bore you with the explanation again, so I'll just let you believe me. And what is the derivative of tan x? Well, it's actually secant squared x. Why is that? Well, you can actually use quotient rule by remembering the trigonometric identities of sine x over cos x equals tan x. So that is all for this video. You should have learned that derivatives have a lot of different rules. We have power rule. Start writing in cursive because it's a little bit easier. Power rule. We have product rule. We have quotient rule. I'm forgetting U's here. And we have chain rule. And then we also have e to the x equals e to the x, turns into e to the x. Then we have ln x turns into 1 over x. And we have all the trig, which you can memorize for your calculus test. So yeah, thanks for watching. Next time I don't know what I'll be going over. Maybe introduce integrals or maybe not yet. I'll think about it. So yeah, see you next time. Thanks for watching.